Hello children, how are you all? Today I am here with our fifth topic from our chapter Matter in Our Surrounding, that is evaporation, and sixth topic, that is plasma Bose-Einstein Condensate. Coming to evaporation. Now we all know that evaporation is a phenomena in which liquid changes itself into water vapor at any given temperature below its boiling point. That means किसी भी चीज़ के उबलने के या बॉइलिंग पॉइंट से पहले जब कोई चीज़ लिक्विड से वेपर में कन्वर्ट हो जाती है उस प्रोसेस को कहा जाता है इवेपोरेशन. नाउ पार्टिकल्स ऑफ मैटर आर ऑलवेज मूविंग, दे आर नेवर एट रेस्ट. In fact, if we talk about that gas, liquid or solid, then all these at a given temperature are having particles in a moving state because they are having different amount of kinetic energy. If we talk about liquid, then a small fraction of particle which is present at the surface and having higher kinetic energy is able to break away from the force of attraction, and then it converts into vapor. Now we have already seen that evaporation and boiling are the two phenomena. If we talk about the comparison between evaporation and boiling, then boiling is a process which is a bulk phenomena and in which the particles of or the molecules of the particles are completely getting changed into vapor in a bulk form. And evaporation is a surface phenomena in which particles from the surface, that means that much particles which are able to overcome the force of attraction, are able to change itself into vapors. In boiling, whole liquid which is present is able to convert into vapor, but in evaporation only surface particles are able to convert. Next, coming to factors that affect the rate of evaporation. Now there are four major factors that affect the rate of evaporation. First one is temperature, second surface area, third wind speed, and fourth humidity. Now we'll go through these factors one by one. First is temperature. Now as the temperature increases, the rate of evaporation also increases. The best example is that when in a hot sunny day, if we keep something liquid outside for a long time, then we'll observe that the particular liquid content becomes half in its amount. Next is surface area. Now, as the surface area increases, the rate of evaporation also increases. The best answer about is nowadays you must be eating your Maggies, your pastas, then you must be eating kheer, rasmalai and everything. So when they are kept in a small bowl, that too a deep one, then it takes lots of time for them to get cooled down comparatively to when they are placed in a plate or a dish which is having a good surface area. This was the two factors. Then coming to humidity. Now the rate of evaporation decreases with the increase in humidity. We all know that humidity means some amount or little bit amount of water present in the wind. So when wind is having humidity or water, then evaporation rate will be decreased because already water is there, so evaporation will be low. Coming to wind speed, this we all know. Then when there is increase in the wind speed, then evaporation, yeah, rate of evaporation is also very fast. The best example is of drying of the clothes which are kept outside after washing, then switching on the fan after cleaning the home. All these are the examples of wind speed. Now coming to cooling caused by evaporation. The cooling caused by evaporation is totally based upon the fact that when liquid evaporates, it draws or takes the latent heat of vaporization from anything which touches it, or losing heat, this anything gets cooled out. That means Latent heat of vaporization is the main cause behind the cooling effect caused by the evaporation. Few examples are given. The very first example is an earthen pot. Now we all know that during hot summer days we usually keep water in an earthen pot, that is matka, to keep the water cool. Now this earthen pot has large number of extremely small holes which are present on its wall. So some of the water continuously keeps on sweeping from these pores to outside the pot. Now this water which is getting outside gets evaporated and changes into vapor and continuously take the latent heat required for vaporization from the earthen pot and the remaining water. In this way, the remaining water loses its heat and gets cooled. Next example is the perspiration or the sweating which is caused by our body to maintain a constant temperature. What exactly happened during this process? Now when we are facing increased heat from the outside, our body increases its temperature from inside. In response to that, our body starts sweating out or perspire, so that as soon as we perspire, the temperature of the body starts decreasing with the sweating and we start feeling normal. The third example is that we should wear cotton clothes in hot summer days to keep ourselves comfortable. This is because we are sweating a lot, and when we wear cotton material, then cotton helps in absorbing the sweat and it easily helps in evaporation of this sweat from our clothes and makes our body feel cool. Comparatively to this, if we wear synthetic clothes or polyester clothes, they does not absorb our sweat and that is why they does not help us to feel cool during summer season. Next, to show the presence of water vapor in air. Now, there is always some water vapor present around us in the air. The water vapor comes into the air from the evaporation of water present in ponds, lakes, rivers, and oceans. Even this water vapor comes from plants by the process of transpiration, and animals like we humans and other small animals give water vapor through breathing process, inhale and exhale. All this water vapor goes into the air around us. Next, the presence of water vapor in air can be shown by the following experiment. Now, what we have to do, we have to take some ice cold water in a tumbler and we have to keep it for a while. Soon we'll observe that water droplets are coming out from the tumbler to its surface. The water vapor present in the air, when they come in contact with the cold glass of water containing ice, they lose the energy and gets converted into liquid state, which results in the formation of the water droplets on the surface area. Next, coming to Bose-Einstein condensate and plasma. Before going for that, we need to see this flow chart. In this, Bose-Einstein condensate, then solid, then liquid, gas, and then plasma is present. And that is showing the low energy or high energy. From this diagram, we can conclude that Bose-Einstein is having very low amount of energy and plasma is having very high amount of energy. Now, what exactly plasma is? Basically, plasma is an ionized gas, that is a gas which is having ions in it, which is very good conductor of electricity and is affected by magnetic field. Now, plasma like gas, it is having an indefinite shape and indefinite volume. We cannot specify the shape of plasma, and ionized gas is the best example of plasma. Next is Bose-Einstein condensate. Now, BEC is a state of matter which is caused at the very low level of temperature. Scientists who worked with the Bose-Einstein condensate received a Nobel Prize for their work in 1995. Now, it is all about molecules that are really close to each other, even closer than atoms in a solid. Now, plasma and Bose-Einstein condensate are the more state of matter. Apart from solid, liquid and gas, we count fourth and fifth state of matter as plasma and Bose-Einstein condensate. Now that was our chapter's topic. Our last topic and the next topic will be numericals based on the conversion of Celsius into Kelvin scale and Kelvin scale into Celsius scale. Till then, keep in touch and try to subscribe my channel so that you can get all the videos whenever you want to get them.